Hi everyone, it's our first Math Game Monday and I'm very excited to share this game with you. I have been using it with tutoring mostly, a lot of my math students, but I have used it in the classroom as well. And the great thing is you can adjust it from like kindergarten all the way to grade 8 and even higher, I would say. So this is the input-output machine game that I like to play. So with the younger kids, you can actually make a physical like a robot style out of a box with an input and an output slot. Or with the older kids, I just like to use a little T-chart and they can look for the patterns just on paper as we go. So let me explain a little bit about what this game is. It's in the patterning and algebra strand of math. Given an input number or stimulus of some sort, it could be a shape as well. You have to play with somebody, I should mention that. The older person, the adult or the older sibling, can give them an output. And they are to guess the pattern and eventually predict, I give you this input, I predict you're going to give me this output. I'll explain. All right, so here we have our T-chart. Player 1 will give an input number, any number you like. Say we choose 4. The other player has a rule in mind and will give them the output number. Here, an input yields an output of 8. So player 1's thinking, it might be adding 4. That could be the rule. As a possibility, let's test it out with another input. 15 yields 30. Okay, so it's not plus 4. That doesn't work then, because the rule has to apply to every single input that we give. Maybe it's times 2. 4 times 2 is 8. 15 times 2 is 30. Let's try with one more. 7 should yield 14. Good. Good. So it works for all 3 cases. That must be our rule. And I always like to write out the rule at the end. So I encourage you to model that thought process for your children or your brothers and sisters, and start out with some easy examples until everybody really gets the hang of the game. And starting with some easy examples always makes the challenges easier. So here's a harder example. I encourage you to pause it and try to solve it right here. So after the 10, I'm thinking, maybe it's at 11. That would get me 21, but that doesn't work for the 5. So 10 gets me 20 if I multiply by 2. It's almost like multiplying by 2, but it's one more. 5 times 2 is 10. Oh, you would add one more to that as well to get 11. And 1 times 2 is 2 plus 1 more is 3. The rule must be times 2 and then add 1 after. Okay? You get the idea. So as mentioned before, if you have a child that would be interested in actually creating an input-output machine, go ahead, have some fun with it. Just make sure you have an input slot and an output slot. A physical cutout where you can insert a blank card or a piece of paper that you can make. And you can have numbers on the cards. You can draw pictures to represent the numbers, like as if on a dice, or you can use shapes. So if you inserted like a heart shape, and the other person would go around to the other side and spit out, for example, this image, and then the child would understand that the rule is spitting out the left half or 1/2 of the shape that they gave. So there you have it. I hope you guys enjoy this game. I hope you play many times with each other and challenge yourselves. I'm going to leave a few sets of questions to get you started at the end of this video. For the older students who understand equations using variables such as x and y, I want you to think about an equation such as y equals something multiplied by x plus or minus something else, and connect that to how this input-output game is played. So for example, how does the x and y relate to the input and output values in a game of this? I'll leave a little note on something to get you started at the end of the video as well. See you guys all tomorrow. Bye.